Hey folks, Professor G here. How you doing? Excuse me. Got a brand new lecture for you here, so forgive me if there's some flibs and flubs in it here and there. Just wrote it over the last couple of weeks. This is content coming from chapters 21 and 22 in your textbook, at least for this edition. Who knows where it'll be a little, next editions, but there's some of the content came from the planets chapter at any rate, and then from just the general astronomy chapter. So it's branching a couple chapters is what I'm trying to say. Okay, so in my classes I've always said that the Earth or the Moon is about 250,000 miles away from the Earth. I guess I could start saying 240,000. We got the approximately there. Okay. There's your average, but if I ask you, it's going to be the Moon is approximately how far away, so you're going to want to look for that number. It moves across the sky from east to west at about 2,200 miles per hour. It itself is fairly small, okay? And the neat thing I wanted to put your attention to is that it is, we've been talking about the ecliptic in previous lessons, where you see all the planets at. The Moon's orbit bounces above it and bounces below it. And that gives it some rather unique movements. As you know, I hope, we've been there. All right. One of the few things in space we've landed on, one of the only things we've landed on with a human. Over a course of, would that be 3 years, 4 years? 69, 70, 71, 72. 4 years. We landed 6 spacecraft, each with 2 astronauts on the surface of the Moon. Now that does not include the guys that got to stay behind orbiting. Okay. So they didn't just send up 2 people, but 2 people got to walk each time. So those were the Apollo missions. And, well, that's all neat and dandy. How about that? They brought back 840 pounds of rock. Yay, rocks. Here's a wonderful picture. Everybody's favorite astronaut, Neil Armstrong. All right, 1969, Apollo 11. Pretty cool. Speaking of moon rocks, there's a piece of one. Lunar basalt 70017 is its name, I guess. You really don't know the, in earth science at any rate, we probably haven't talked about rock types yet. This is an igneous rock, similar to what you get out of a volcano here on Earth. It's magma. It itself is 3.7 billion years old. Okay. The Earth, for reference, is 4.3. The Earth is almost, or the Moon is almost as old as the Earth. This is not stating the Moon's age here. So just saying how old this rock is. All right. We always see the same side of the Moon because it rotates at the same speed as the Earth. You see that approximately there. Technically, I guess you see 59%. You see, the middle portion all the time, and then you see maybe a little to the left at some point and a little to the right at another point. All right. Dark side of the Moon, well, you know how that goes. It's all dark, really. Right? It's just reflected light. But anyhow, so we did see the dark side of the Moon in 1959 when we when we sent up I'm going to assume this is a probe called Luna 3. Oh, and by the way, it's kept in sync by the Earth's gravity. All right. What was my point in... Oh, I know why I wrote this slide. Okay, gravity's a function of... let me rephrase that. Weight is a function of gravity. All right. Mass is a measure of your matter, as you know from first lab, right? So because the moon is so much smaller and it's less dense, okay, you've probably seen those videos of the astronauts hopping around like little kids in a bouncy house, right? Because of the super low gravity there, a 150-pound person would weigh what would feel like to them as well, 25 pounds. So that had to take some getting used to, I bet. So low gravity, this is about the atmosphere of the moon. You know that the Earth's gravity holds our atmosphere to us. So the very low gravity, gravitational pull, gravitational field, whatever word you want to use, of the moon is one of the reasons there's no atmosphere. There may have been at some point. You also know that for a large part, volcanism, outgassing, is responsible for our atmosphere, okay? We should have talked about that already in class. And as I said, there may have been, when there was active volcanism, maybe an atmosphere stuck around for a little while, again, low gravity. So because of no atmosphere, there's nothing, there's no greenhouse gases, anything like that. There's nothing to hold the heat. So man, talk about a temperature bounce, okay? It can get really, really warm, and it can get really, really cold. There's good news, though. Because there is no atmosphere to get in the way, we get a really amazing view of the surface of the moon. Talk about amazing. Topography. Topography is sort of the lay of the land, if you would. You might be familiar with something called a topographic map. Okay. Basically looks like a road map, but there's all kind of squiggly lines all over it that indicate hills and valleys and plains and whatnot. Topographic map of the moon would be pretty cool looking. In fact, I think I have some images a little later. They're not maps per se, but so the highest spots on the moon, 6.7 miles above the average surface elevation. I couldn't quite decide if we could call that sea level, for lack of a better word. Okay, but I'm guessing it's our equivalent of sea level. And then the lowest spot's 5.7 miles below. So again, just a huge amount. And in the topography world, we call that relief, the difference between the highest elevation point and the lowest elevation point. Boy, that's a lot of relief. No atmosphere means something else. No weathering and erosion. So there's not streams moving sediment around, wind blowing sediment around. Again, little to no gravity pulling things down. Things just kind of sit there and they don't wear away. So the moon has looked, I'm so used to talking about the Earth, I keep saying Earth. The moon has looked very similar to what it has for a very long time, we can assume. So, some words you might know: Mare, and it is Mare, and Highlands. So when you look up at the moon at night and you see the dark spots and the light spots, the Mare are the dark, and apparently when we first looked up we thought they were the oceans of the moon, the seas of the moon, okay? And then the lighter colored areas, those are the highlands. And we're going to talk more about those in the subsequent slides here, so I don't want to spend too much time right now. But So the mare are lowlands. They're dark and smooth. They are, again, that word basalt shows up. They're lava flows. They're puncture marks, okay? Impact basins here, okay, it's a proper word. The asteroids, if you just want to use a generic term, meteors, whatever, bashed into the moon and hit so hard at a point when there was still perhaps some molten material inside the moon itself, and they punctured and let that material flow out. Again, we've seen both sides of the moon now, and interestingly enough, we see these Maria, plural, mostly on the side that we can see. There's one tiny little one here. A few others. They appear to be the purple. There's one down there. Good sized one. This is elevation, so that's negative. So these are big, like we said, puncture holes, okay? So this is a digital elevation map, if you would. And this is a photograph. So the darker colors down here are below sea level, like we talked about earlier, for lack of a better word. And these are your higher spots. And the yellow is normal. Yellow to green is fairly normal. Okay, is this going to work? Well, that one works. This one might not spin. This might just be single-sided. This is a very nice digital elevation model. The previous one was just colors. That was, took some work, don't get me wrong. But this one looks like if you felt it, it'd, certainly have some depth to it. Isn't that nice? I think if you go to the real one, it lets you move it by hand. I could be wrong though. This is one somebody actually made and posted it. Uses the colors, and again, blues being the lowlands, the oranges being the oranges and yellows being the highlands. There's some actual photographs. So I saw two different numbers here. I saw over 100,000 and I saw 300,000 plus craters with a diameter greater than 0.6 miles. No atmosphere, no weathering and erosion. Craters are still there. I think I have a slide. I don't have a slide. I'm sure I talk about this at some point. People look at the moon, and if you've seen pictures of Mercury, not everyone has. They're both very, very heavily cratered. And you look at Earth, and well, we don't really see a whole lot. We have every reason to assume that we got hit just darn near as many times, and Venus and Mars too. But on Earth, we've got weathering and erosion. We've got sediment building up. There was a guy that had just started back in the 2000s, I guess. Be interesting to see what he's doing now. Using a ground penetrating radar to go crater hunting. So it's probably got a show on Discovery Channel by now. I don't know, but at least a couple papers came out of it. That would have been some neat work. I had already started my graduate work, so wasn't an option for me. But neat stuff. I guess it was late 90s, technically. All right. So, solar nebula theory, which we probably haven't talked about yet, talks about the coming together of the solar system. We actually might have Yeah, we did talk about it. Accreting, okay. Um, so the idea here is, well, that was going on. Something roughly the size of Mars, and they always say a rocky body. Well, if it's the size of Mars, and we call Mars a planet, um, and Mercury's smaller than Mars, it's a planet. And they named the dang thing Thea. Okay, I don't know why they just don't say there was another planet. Probably because we never saw it, so they don't call it wouldn't call it a planet, but smashed into the Earth. Okay, about 60 million years after the Earth had formed, so it was still fairly early on. Sounds like a long time, but again, the Earth is 4.6 billion years old. So I hope I said that number earlier. Something in the back of my head says I said a different number. I lied if I did. If I said 3.5 by any strange chance, that's the when we have life on the planet. I hope I said 4.6 billion earlier. Anywho, so 4.6 billion years, 60 million years into that, nothing. Okay, so fairly early on, and that's important for a reason. We'd undergone density separation, okay, and there was a whole lot of molten material underneath the crust of the Earth. And as such, we say that the moon is composed of mainly of mantle rock, all right, crust, mantle, core, right? And it formed through the process of accretion as well. The issue is that we see the moon's rocks, relatively speaking, relatively lacking in iron. Okay, there's been a handful of theories, by the way, over the years, hypotheses, theories possibly as well, on the formation of the moon, and this is where we currently stand: the Theia, the impact origin. Okay, impact origin. One of the ones that really had a decent amount of pull up until this Theia idea was that it was just leftover riffraff when solar nebula was going on. And it just got sucked into Earth's gravitational pull, stayed in orbit, but once we figured out some things about it, it didn't fit anymore, didn't work. So once the moon came together, you're thinking, well, wait a minute, if the Earth did density separation, maybe all their iron is deep down in. Yeah, but its core is only 20% of its diameter, which is nowhere near our ratio. I think I saw numbers that say our core is like closer to 50%. Okay, so that still goes back to equaling very low iron. Surface rocks are made up of mantle stuff, and this is neat. When I moved to this part of the country, an orthosite became a mineral that was on my radar. Well, you guys have an orthosite. Here we go. In the Adirondacks. Okay, it's rather rare at the surface of the Earth. It's found on the moon. It's found inside of the Earth, and in the Adirondacks, and a couple other places. Very few. You find it at the surface. So, kind of neat. Let's make sure I left this one kind of quick. I apologize if you're still looking at it. I personally thought an orthosite was a lot darker, but apparently not. All right, we're going to end this portion of the recording here. You guys have been, the few that responded to my questions indicated that you liked shorter videos. So I haven't been hitting the 10 to 12ers, but at least we'll keep this one at 20 minutes. So more later. Bye.